Welcome back, or welcome for the very first time to Molecules Matter with Dr. Dan. If you've ever taken a supplement, eaten a plant, or heard someone say this herb is good for stress, I want you to pause and ask a deeper question. Why? Because plants don't work by magic, they don't work by vibes, they work by molecules. And in this podcast, that's exactly what we're going to unpack. One molecule or one class of molecules at a time. Today's episode is all about Withanolides, a fascinating class of bioactive molecules found in Ashwagandha, a plant that's been used for thousands of years and is now one of the most studied adaptogens in modern nutritional science. But here's the thing. Most people talk about ashwagandha like it's a personality trait. Good for stress, helps cortisol, calming but energizing. Those statements aren't wrong, but they're incomplete. Because ashwagandha doesn't do anything. Withanolides do. And today we're going to zoom all the way in. Where withanolides come from, what they actually look like at the molecular level, why the plant makes them in the first place, and how those same molecules interact with human stress biology, inflammation, metabolism, and brain function, according to peer-reviewed research. By the end of this episode, you'll understand why withanolides matter, not just that they do. So let's start with the name. Withanolides are a class of molecules, not a single compound. That's important. When you hear vitamin C, you're talking about one molecule. When you hear withanolides, you're talking about a family of structurally related compounds. The most well-known ones include withaferin A, withanolide A, withanolide D, and withanoside 4 and 5. Each one has slightly different biological effects, but they all share a common molecular backbone. And that backbone puts them in a broader chemical category called steroidal lactones. That phrase alone tells us a lot. Steroidal. They resemble steroid hormones structurally. Lactone. They contain a cyclic ester ring that affects how they bind to proteins. This structural similarity to human steroid hormones is one of the reasons withanolides interact so effectively with stress-related signaling pathways in the body. Not because they are hormones, but because they can talk to the same molecular machinery. Where withanolides come from? Withanolides are found primarily in Withania somnifera, commonly known as ashwagandha or Indian ginseng. They're most concentrated in the roots and the leaves. The leaves are often higher in withaferin A. This matters because not all ashwagandha products are chemically equivalent. Root-only extracts, leaf extracts, and full-spectrum preparations can have very different withanolide profiles, which mean different biological effects. From a plant's perspective, withanolides aren't nutrients. They're defensive molecules, which brings us to an important concept you'll hear a lot on this podcast. The molecules that help plants survive stress are often the same molecules that help humans adapt to stress. The chemical structure and class. Let's zoom in. At a molecular level, withanolides are C28 steroidal compounds. They're derived from an ergostane skeleton containing a lactone ring formed by oxidation of the side chain. In simpler terms, imagine a classic steroid framework, 4 fused carbon rings, similar to cortisol, testosterone, or progesterone. Now, modify it slightly, add oxygen groups, close part of the molecule into a ring, change its flexibility and polarity. Those subtle changes are what turn a hormone into a signaling modulator rather than a direct hormone mimic. This is why withanolides don't replace cortisol or testosterone, but they instead influence receptor sensitivity, stress signaling cascades, and inflammatory gene expression. Structure drives function, and withanolides are structured to interact without overpowering. How the plant makes withanolides. Ashwagandha doesn't wake up one day and decide to make withanolides. It builds them through a tightly regulated biosynthetic pathway, starting with basic metabolic building blocks. Here's a simplified version. The plant uses the mevalonate pathway, the same foundational pathway used to make sterols and isoprenoids. This pathway produces triterpenoid precursors. Enzymatic steps modify those precursors, adding oxygen atoms, closing rings, and creating the lactone structure. The final withanolide profile depends on plant age, stress exposure, soil conditions, whether the compound is made in root or leaf tissue. Plants under stress, heat, drought, pathogens often produce more secondary metabolites, including withanolides, which tells us something critical. These molecules are part of the plant's stress response system. From the plant's perspective, withanolides are multitaskers. They help deter herbivores, inhibit microbial growth, regulate internal oxidative stress, signal damage response pathways. Withafrin A, for example, has strong antifungal and anti-insect activity. That's not an accident. Plants can't run away from stress, so they evolved chemistry. And when humans ingest those same molecules, we're essentially borrowing the plant's biochemical survival tools. Now, let's talk about humans. When withanolides enter the human body, they interact with multiple systems, not by brute force, but by modulating signaling pathways. Number 1, stress and cortisol regulation. Multiple randomized controlled trials show that standardized ashwagandha extracts reduce perceived stress scores and serum cortisol levels. Mechanistically, withanolides appear to influence the HPA axis, cortisol receptor sensitivity, and stress-inducing inflammatory signaling. This is not sedation, it's stress normalization. Number 2, anti-inflammatory effects. Withanolides inhibit NF-kappa B activation, pro-inflammatory cytokines like TNF-alpha and IL-6. That matters because chronic psychological stress and chronic inflammation are deeply intertwined. Lower one, and you often lower the other. Number 3, neuroprotective and cognitive effects. Withanolides have been shown to promote neurite outgrowth, protect neurons from oxidative damage, support synaptic signaling. This helps explain why ashwagandha is often reported to improve focus under stress, sleep quality, and mental resilience, not by stimulation, but by lowering the noise floor. Number 4, metabolic and hormonal effects. Emerging research suggests that withanolides may improve insulin sensitivity, support thyroid hormone balance in hypothyroid states, and support testosterone levels indirectly by reducing stress burden. Again, these are context-dependent effects, not hormone replacement. Here's where nuance matters when it comes to how to use withanolides and dosing. Most studies use standardized extracts, not raw root powder. So the typical clinical dosing is 300 to 600 milligrams per day of the extract, and that extract needs to be standardized to 5 to 10% withanolides. Important considerations are the following. Root-only extracts tend to be gentler. Leaf extracts are more potent, but can be overstimulating for some. And the effects are cumulative, not instant. This is not caffeine. This is not melatonin. Withanolides work by gradual recalibration. And safety matters. Withanolides are generally well tolerated, but please avoid during pregnancy and have caution with hyperthyroidism or immunosuppressive therapy. And remember, anybody with a pre-existing medical condition should consult with their personal physician before trying any nutritional supplement, before trying any new dietary regimen, and before doing anything new to your health routine. So let's zoom back out. Ashwagandha doesn't lower stress. Withanolides do. And they do it not by forcing the body into calm, but by teaching it how to respond more intelligibly to stress signals. That is the theme of this podcast. Health isn't about hacks. It's about molecular literacy. If you enjoyed this episode, follow Molecules Matter with Dr. Dan and listen to the next episode where we will unpack another molecule hiding in plain sight. And if you've found value here, leave a review. It helps this science reach more people. Because when you understand molecules, health stops becoming mysterious. I'll see you next time.